Hello everyone, my name is Mota and welcome to the first episode of Doing Random Stuff, or DRS for short. Now, just to clarify one thing, this is not a tutorial, this isn't rehearsed nor is it scripted, and the reason for that is so that you may understand how exactly I approach this particular area of shading particles without me looking at a script or at a separate instance of Blender. So what I have over here are two particle systems, and the first one is the main particle system. The second one over here is simply to add a bit more texture to the first one. It's going to be less visible, but it's going to certainly make a difference. Now, I do have to say that it is a bit difficult to see the particles. This is only an initial simulation with about, I think it was 200,000 particles. I will end up with 2 million particles in the end. This is only so that we can shade the particle system without experiencing many difficulties with the CPU. The same thing applies to this other particle system, which has 400,000 particles, and in the final simulation it will have 4 million. I'll first, before actually doing any shading, I will hide this particle system so it has no effect on the CPU, and let's get started with this one. First of all, I will have to rename the material. That is much better. Now, without any further ado, let's get started. Now, quite recently, I changed my YouTube channel's cover from this to this. And one thing that I really like about this newer image are the textures in the background that have a very strong and vivid red shade to them. This is what I'm going to try to replicate over here. So without any further ado, let me begin by adding a particle info node, which is usually the default way to begin shading a particle system. Now let me see exactly what the velocity output looks like. Angular velocity. All right. First, before I start to work on any final effects, I want to establish the basic color scheme. So what I'm doing over here is I'm adding a color ramp for the color scheme and adding an emission shader so we can connect the color from the color ramp and a brightness value from a separate color ramp directly to the strength of the emission shader. This will, of course, control how bright the particles will be. Multiply this by 3 for now. Now, one thing that is important to note is that I'm using the Filmic log encoding base over here in the color management settings. And that is quite important, as it has far more accurate colors than sRGB. As for the look, I'm using base contrast, and that's about it for the post-processing or the rendering area. Now I will simply add a color that looks good on this particular object. Now what you're seeing over here is the basic color scheme that I have just established, and I think it looks pretty good. It doesn't look perfect, but over time we may enhance it to suit our purposes. Now, I'll start to add a bit more details to the color itself, and for that I will remove these brightness values and the emission shader, because for now I just want to focus on the details that we will be adding and then see how exactly we will separate them into color and brightness values. So, let's take a better look at the velocity output and see what we can use of it. One interesting way of using the velocity output is by separating its RGB values and combining only the ones that you need afterwards. Now, usually what I end up doing is adding a math node and turning it into absolute, because the velocity value has some negative values in it. So, using an absolute node will convert those negative values into positive ones. This is only useful sometimes. It a lot of the times makes it quite blurry and may even sometimes remove the details, so it is quite optional and I usually use it, but of course there are the exceptions. Now let me begin by cutting out this red value over here and putting a color ramp to see how exactly this looks. Alright, apparently the green output over here gave me the best results. And I think that this is what I'll be sticking with for now. I may change it later, but right now it looks quite good for its purposes. So now that the basics have been established, I will start to move on to the more advanced area and start to add some of the smaller details. One interesting way of adding details is by adding a noise texture and using the angular velocity output as its vector input. So, as an example, here's a noise texture. Let me pause the render over here for a while. Let me increase the contrast of the noise texture to make it easier to see. As the angular velocity value from the particle info node contains x, y, and z information, we can use it as a vector value to map the textures according to the velocity of the particles and the direction that they're moving towards. One interesting way of visualizing a texture in a particle system when you're using angular velocity or velocity as the vector value for that texture is by adding a color ramp and making one side of it red, usually the black side, and the other one keep it completely white. Move this to the center, 0.5. Afterwards, you connect the color value or the factor value of your texture to the factor value of the color ramp, and now the result can show which parts exactly of the particle system are dark, in this case red, and which parts are white. This makes it a bit easier to establish a correct scale for your noise texture and the correct amount of distortion that you'll be adding to it. Sometimes an interesting way of actually using this color ramp is by adding stripes to it, by making both of the extreme sides white, and by keeping the middle area red, we have a different look entirely. I'll add a bit of distortion to change the way this looks. Usually I keep the detail at 2. If I increase it too much, the render time will increase, and will make it more and more difficult for it to be rendered with the GPU compute device. Therefore, keeping the detail at a low value, for me usually 2, would be a better idea. Now that I am pleased with the result of the noise texture, I will replace this color ramp with one that is a bit more accurate. So, turn the red areas into black. Maybe I'll keep it red just to see the exact difference that it made. About what I expected over there. Most of it is now red. Not really a big issue for now. So now what I'm gonna do is turn this red value into a black one, so we can get a bit closer to the final result. And move these white areas further away from the center, so we can have more detail and more color variation throughout the whole ramp. Now let me once again add the emission shader that we removed earlier on, and connect the color value to color, multiply this by 5, so we will have a brighter result, and unpause the render view. So, what we can do is add these details over here to this already existing shader, which is probably what I will do right now. So that I will now add a mix RGB node and connect this over there, increase the factor to 1, and let's see how exactly this looks like. Quite interesting. I might probably have to do this. Disconnect that. And we ended up with this. Now, although this looks quite good, I really want to add a few more details to it. One detail that is particularly interesting to add are very tiny areas that are harshly lit. So I would probably use the noise texture over here, add a color ramp, and increase the contrast of it to the point where we only have a very few white areas. These areas are what we're going to be using to brighten certain parts of the simulation. Should probably invert this and see what exactly it looks like. Now this looks quite good for the current purposes. This is probably something that I will be using right now. Turn this to screen. Right, I should probably mix these two together like this. And this gives us a bit brighter result. One problem that can be observed is the fact that these areas aren't exactly brighter. They are only as bright as the factor value of this multiply node over here. So what I'm going to do is multiply these ones by 5 and add them to the current brightness. And this is about the result that it will give us. Now, one benefit of using this mix shader is you can change the color that we're adding over here. Let me see if any shade of blue would actually look good. This looks quite interesting. In fact, I did not expect blue to look exactly great with this particular simulation. I was planning that for the second one, but this one looks quite decent actually, but I believe a nice bright orange would do the trick. So now we have this simulation over here. I'm pausing the render now just to add a few more details that I should probably add right now. And this looks quite good for the first simulation, but I do have a few ideas of extra details that we can add to make this look a bit better. Now, one particular detail that I'm thinking of is making the very initial parts of this particle system a very bright blue. Now, I'm not sure if this idea will exactly work out. This is mainly the mentality that I approach this particular area of shading a particle system with. I don't exactly know what I'm going to do. I only have a very vague idea in my head, and the only way I can understand exactly what I will end up doing is by making things up as I go along, which is actually something that happens quite often with the way I approach things in Blender. So now what I will do is disconnect the emission shader over there and add a completely new one, or just duplicate the current one. And before I do anything, I want to establish exactly when I want the particle to be this light blue color. And I want it to be right after the particle was born for about 1 or 2 frames. So what I will do is add a math node and divide the age of each particle by their lifetimes. This will give us an interesting gradient that we can then invert over here. And now if we move this black area to the left, you can now see the places from which the particles were born. They're actually, in this particular simulation, they are born from already existing particles. I'm using the particle instance modifier, by the way. They're born from these larger particles that you can see over here. And that is what causes this interesting looking effect, which is the reason why I think this idea might work out. Now I'm proud of the look of the color ramp, and I will now move on to the velocity information that we will be using to add a bit more texture to this simulation. So I will duplicate these nodes that we created earlier, as they are quite useful. Get the combine RGB node over here. And by the way, I apologize for some of the background noise that you might be hearing right now. I'm not in the most professional setting, so background noises are to be expected. I'm planning on buying a microphone stand and things like that would actually help me, which for some reason I decided to be unreasonable enough not to buy earlier, but hopefully it will work out this time. And only now I'm realizing how useful the angular velocity output actually is. You know what? In fact, I might just change things completely over here. Well, that was not expected. I should probably multiply that by a smaller number. In fact, I might actually not multiply it at all. I have a different idea. I will save that idea for later, but for now, I'll just keep this connected to the velocity output. So, what I will do now is actually I might make these things a bit longer, just about over there. So, I'm going to combine the green value. In fact, what I'm going to do is flip the red and green values over here, see if I can come up with something interesting for another noise texture that I will be adding right now. Now, I'm quite pleased with this current result, though I think it's a bit too clean, so I will add a few more details to it. I have an idea of how exactly we might approach that. And after I'm done with this, I will make the particles fade away slowly over time instead of disappearing abruptly, just so they'll look a bit more natural and Now, what I'm doing right now is one thing that is quite crucial to stylistically shading particle systems, and it basically is messing around with these values until you get to something that actually looks interesting. Out of all the values that this math node possesses, I believe tangent is quite good for this particular purpose, although it has some extremely bright spots that I suspect are beyond the value of 1, which is the maximum value that a desktop can preview. It's 100%, so I will add a color ramp to limit those values and multiply this by a number smaller than 1. Now I will connect the value to the color, also connect it to the strength, increase the strength, probably multiply it by about 30. It's quite a big value. I'll now add a color ramp over here. Make this a very strong blue. By the way, one thing that I really like to use over here, I like to use the color mode of hue saturation and lightness or hue saturation and value. And the blue color that I want for it is a more desaturated blue. I don't want a very vivid blue, as it wouldn't look particularly good with the strong red right next to it. This blue would be in very small amounts just to balance out the red a little bit. So now it's time to add these two together. What I'll be doing right now is duplicating this math node over here, connecting this value to it, and connecting these over here. And now this gives us a very interesting looking result. Not sure if this is that much better than what we had previously. Maybe I should make the blue a bit more saturated. Should probably reduce the brightness over here to about 20. In fact, 30 seemed to be quite fine. Keep it there. Maybe increase the saturation over here just slightly. And now let's take a look at this. And for now, it looks quite good. But one thing that it definitely needs is making these particles fade away over time so that they won't abruptly disappear and look unnatural. So, for that, what I will do right now is divide once again the age by the lifetime. In fact, I probably don't need to do that as I have the node over here, but just to avoid some future confusion, I will do it again. As you can see, the node tree over here is quite complex, so I do not want to make it even harder to understand. Now I'll pause this rendering for a moment, add a color ramp and invert it. And what I'll do right now is increase the contrast a little bit so that they will only decrease their brightness when they are close to actually fading away. So something like this could be good. And currently only the color itself is being faded away over time, so I will actually have to do the same thing to the brightness of the whole particle system. So to make it even more confusing, let me add a multiply math node over here and connect this over there. I'll change the position of the white area of the gradient a little bit, and this might actually work. So maybe this might actually be enough for the first particle system. Personally, I wouldn't really make it any more confusing than this. One thing that's actually really important to remember is if your node tree is extremely complex, it'll take much more time for Blender to actually render the image, and maybe even in some cases you will have to use the CPU device instead. So in fact, before I'm going to do any rendering, I'm just going to simplify things and organize things over here. One thing that I certainly do not need are these two absolute math nodes. And one thing that you can do is press Ctrl and H to remove an unused output or an unused input. This is actually quite a useful thing. Most of the times you do not need the alpha output in the color ramp node. What I'm going to do right now is get back to the solid view mode, save the file, and I want to do two test renders, in fact, one without motion blur and one with motion blur. So I will do the test render right now and let's see what the final result will look like. Alright, so here are the rendered results. And this is the render without motion blur. I'm quite satisfied with the look of it. I'm quite pleased with it. In fact, I was surprised by how interesting and how good this looks without motion blur. In fact, one of the things that you can observe is that this that doesn't have motion blur renders almost 2 times faster than this that has motion blur. There has to be a good balance between the look and the render time. And unfortunately this time, rendering with motion blur wasn't really the ideal thing. Now, the difference between the first and the second render is only one of about half a minute, except when I will add more particles, which I will, I'm only previewing the 10th of the final amount of particles that I will have. The render time will increase quite heavily, and it will become quite difficult to render everything. And I will also add more other different objects like a floor and background elements to make the whole thing look more interesting, and that will also weigh on the render. And sometimes it will take hours to render a single frame, and currently I have 180 frames on the timeline. So it's always great to take measures that reduce the render time before you'll actually start to experience problems. But for now, I think I'm done with the first part. I may in fact add a few more details, but for now I'm quite pleased with this render result. I may change it later if I'm not exactly completely satisfied with it, but for now it looks pretty good. I will move on to the second particle system right now. So let's get started with the shading of this other particle system. In fact, let me first make it visible. Let me first make this other one invisible so that it won't weigh on the GPU. And let's get to this one right now. And for this one, I want a bit of a different sort of shader. I want to balance out the amount of red that we see in the first particle simulation with a bit of cyan and blue from this one. Now, the thing that I want with these particles is to make them only visible when they're actually moving. Because as you can see from the footage on the screen right now, most of these particles abruptly appear somewhere between frame 1 and 5, which is a bit of a problem since a lot of these particles aren't moving. Just add a particle info node over here. Use a grayscale version of the velocity output. Alright, it's going mainly towards the x-axis. Angular velocity. So what I'm going to do to desaturate this velocity output, I'm going to add a separate RGB node. And of course make sure that there are no negative values in it. Connect these over here. Now instead of adding a combined RGB, I'll just add a color ramp to make sure that it clips at 1. So in fact, there are 2 ways of dealing with brightness. One is to do what we did in the last particle system and connect the brightness value to the strength input of the emission shader. Another strategy is by using a mix shader and mixing a emission shader with a transparent shader, something like this. And so what we can do is just use one fixed value for the strength input over here and use a brightness value for the factor input of the mix shader. So the parts that should be brighter are mixed more with the emission shader, and the parts that should be darker approach more the transparent shader. Now that we have the basics established, I should probably add a color ramp to change the contrast a little bit over here. So I think that looks pretty good. Let's now establish the colors. Duplicate this separate RGB node. Yeah, so this green value looks quite interesting in my opinion. Let me see what this looks like if I use an absolute math operation over here. Alright, blue certainly looks very good. And I should probably start working on the basic color palette. Now, of course, this is a very basic and initial state. I haven't really connected anything to that yet. I'll in fact begin by adding an emission shader and a transparent shader. So let me just connect the output over there. In fact, hold on. Let me just connect this first, and then connect this guy to this second one that we created just now. Well, I guess it doesn't look completely perfect over there, so I should in fact connect this over here. Something like this should probably work. In fact, I'll be multiplying this by a very dark value, say 0.2. Something like this should definitely be good. I'll make it brighter over here. So the interpolation to ease. Alright, this certainly looks quite interesting. Let me add a bit more of that dark blue. Move this over there a bit. And I think For now, this looks quite decent for this basic area. Let me darken this just a touch. Let me move on to some other details. So I'll just test out what it looks like if I add these together in one of these math operations, and now it will be once again the same thing that it was last time, except I think I already found quite a good operation. So in my opinion, logarithm looks quite good. Let me connect red to that. In fact, compare red and green. So let me add a color ramp to make sure that it clips out at 100% white. And that looks quite good. Now I should probably add an absolute math operation over here. And something like that should probably work out quite well. I'll just add a reroute over here that I just did. And I'll replace that with a mix RGB node. Connect these guys over there. In fact, what I'll do is connect this guy directly to the screen node over here that we have. Yes, I think this would do. Maybe overlay. Let me see. Where is it? Maybe it'll actually look better. Let me turn this interpolation back to linear. Alright. Let me try to use a lower value over here, like 0.6. Right, they're quite oversaturated, I know. But hopefully the result won't be too overwhelming. And for now, it looks quite neat. Yes, I do like the current result. In fact, I'll actually just turn this back to linear. And yeah, we can see much more detail than we did with ease. So definitely linear would be the way to go. Let me just once again make this a bit more blue. This has to be quite a dark simulation, much darker than the previous one. The intention of this simulation is to balance out some of the red that we had in the previous one, but of course it can't be an equal 50-50 amount. That would look way too overwhelming. So that's why this would be darker than the last one that we did. I'm now looking for a different value that we can add. In fact, I'm planning on adding some red to this one too, but only with the particles that are moving the fastest. So I think by connecting the velocity to this separate RGB node, we might find something interesting. Yes, blue definitely looks quite good. I'll add a color ramp and brighten it up a bit so you can see it a bit better. In fact, hold on, let me delete this color ramp just for a second. No, I'll just reset it. Everything back to default. And add an RGB curves node. Brighten the whole thing up. Right, now we're getting much more detail than we got previously. So something like this should definitely do the trick. Get this back to B-spline. And now we can increase the contrast. Oh, let me pause this just so we can do this a bit more freely. Alright, this actually looks quite good. Yes, this looks very good. I like it. So I'm actually going to separate these a little bit more from the rest of the node tree, as these are going to be working with a completely different color palette. I should probably duplicate this. In fact, let me just duplicate that and start already changing the colors over here. So quite clearly this would have to be a darkish orange. Something like this should probably work out quite fine, at least for now. Let's add a color ramp, connect the red value to this, and connect these two together with a multiply math node. Brighten this up just a bit more. Alright, I think that looks pretty decent. Now let me duplicate these over here. We're not going to be using them twice in the node tree. I think too many shaders will slow down the rendering process, which is not desirable. That's why I'm only going to be using these 3 nodes once, but I'm going to just duplicate them for previewing reasons. I'll delete them later. That looks surprisingly good. Maybe I should connect things over here. In fact, I'll use a completely different color ramp for this. I'll make it a bit brighter than it is. I should probably add more contrast over here. So I'm going to add another black color over here and move it a bit closer to the one that we have. So what we have right now actually looks quite good. Let me just move this white value over here, darken this up a bit more. Now what we have to do is mix these two together. That'll be a bit difficult. I'll have to figure something out right now. So what I'm going to do right now is I'm going to add a math node and set the operation to add. The current value that we have for the strength is 5. And what we are going to do is add 10, but that would be according to the brightness of this simulation over here. So that would be a bit of a difficult thing to do. Alright, I think I see what I should do. I'll add a mix RGB node and set this to screen and take this value that's going to the factor value of the mix, put it down over there. So now I'm mixing these two brightness values to add that to the final mix shader. So right now I'm going to be connecting this to the emission shader over here, because what I want is for this part of the shader that you're seeing over here, I want this to have the brightness of 5, but this second area that we created to have the brightness of 10. I want these red areas to add some bright large-scale details to the simulation. So what I'm going to do is connect this over here, and I will multiply this by 10. Connect this over there, this to this second input. Once again, using a mix RGB node, I will be mixing this with the second color ramp that we created. So the first color ramp with the second color ramp, and using as the factor value for that, this over here that we created. So hopefully now we can see the red areas that we created, and clearly there's something very wrong. I did not connect the mix properly. So what you can see here is that it sort of worked, but we need more contrast. So I'll just add a color ramp, and I'll just move the white value of the color ramp towards the left. And we can see a bit of an improvement over here with the color. Let's see, this is what it looks like. I should probably turn this to ease to add a bit more contrast to it. So this is starting to look pretty decent. Should probably darken this a bit more. Now I can see that this doesn't look particularly good, at least for now. What I'm going to do to avoid this problem is I'm going to add some more light details into the whole thing. So let me pause the render. Let's see, I should probably use the velocity output over here as a vector value for this noise texture. Continue the rendering. And in fact, that already looks quite good. Let me just duplicate that in case we need to see it again. I should probably delete these ones over here, as we're not going to need them anymore. In fact, now that I'm tweaking these results quite a lot, let me inform you a little bit about what I'm planning to do once again with my channel, as I have a few ideas of change. But one thing that I'm planning to do is start to work on photorealism. Of course, I'm not going to move away from the whole particle and smoke simulation thing. So yes, I am planning to work with photorealism, but I am not planning to slow down anything with particle simulations and smoke simulations, as they're really the most successful things in my channel. And hopefully it will work. Now, of course, if you have watched the video this far, you should probably comment what you think about it, if you think it's a good decision for me to start working on photorealism, but just informing you so that it won't be much of a surprise when it occurs. Maybe this might actually look a bit better. Yes, this definitely looks better. Let me turn this to overlay, see if there's much of a difference. Yes, there definitely is. In fact, I should probably replace this color ramp with an RGB curves node. That might actually work out a bit better. Let's just see how this will work out exactly. In fact, let me just connect the Vira directly to the RGB curves node and start adjusting the contrast like this. Here's the thing, I really like this pattern that I'm seeing over here. I actually think it might be a great idea to replace this thing that we created earlier with this pattern that we're adding right now. I think that might actually give us some more interesting results. Now let me just first work on actually making this look decent. Turn this up to 8. Right, I think I should increase the brightness of the whole overlay thing. So let me use another color ramp. That actually looks pretty decent in the color ramp. Should see what this looks like in the end. This is what I was planning. This is what I wanted for this simulation. This actually looks great. I like it. So what I'm going to do is what I was planning on doing earlier, which is using another noise texture. Let me see what it actually looks like. That looks quite interesting. I should probably see what this looks like if I separate the RGB values and just connect the green and blue values, because the red value is very bright in this case. So I want to see what this looks like without it. That looks intriguing and weird. Apparently the red does quite a lot. Maybe I could just use a math node over here and turn this to multiply. Start multiplying it by a lower value. That looks quite interesting. Should probably just use a 0.6 over there. Right. Let me connect the factor of the noise texture to the color input of the RGB curves node. And now, hopefully this will work when we combine these two over here together. Let me disconnect the current one and insert the second one in replacement. And, oh, that actually is starting to already look great. Let me use a higher value over here, 0.8. In fact, let me add these two together. Let me pause the render first. This is what this guy looks alone. Let me just increase the contrast a bit more. Well, let me decrease the scale of this noise texture and increase the distortion a bit. This might probably look a bit better than it did earlier. Now let's turn this to 0.6 or 0.7. I should probably keep it at 0.6. I don't want to go too far. Yeah, this adds a bit of an extra detail to it, but let me just see if it does much of an improvement. So I'll do a test render right now. First one will be with this node that we added. The second one will be without it. So I'll come back in a minute. So here we are. This is what it looks like with the whole thing connected. And this is what it looks like when it's not connected to the whole thing. Now, there is a difference, and there's a visible amount of color variation that we're losing when we disconnect it. So I'll keep it on over here. In fact, what I'll do is I'll add a bit more color variation over here, since as you can see, a lot of this blue is staying the same, because as you can see, there isn't really that much hue variation, which would actually be very useful. And the render time difference is about 5 seconds. So that's quite a small render difference for quite a good benefit that we're getting, which is more color variation. And I think that is good. So I'll keep it on. And I think that would be about it. Let me just separate these a bit more to be less confusing. Now, as you can see from the render, we didn't really have that many particles. And the reason for that, I may have explained this in the beginning of the video, but it's just for previewing reasons. So currently I have about 400,000 particles over here. Let me check. Yes, 400,000 particles. In the end, after I finish this video, which would be quite close to now, I will end up actually multiplying this number by 10, so I'll end up with 4 million particles. And the same thing applies for the first particle simulation that we did. So 2 million particles with the first one, 4 million with this current one. Now, this increase in the number of particles may lead to me having to decrease the brightness of this whole simulation, but other than that, there isn't really something that I'd usually change when I modify the number of particles that there are. So I think that is actually good. So I am quite pleased with the result. I'll make a quick test render right now with both of the particle systems just to see if they actually look good together. So here we go. F12. Let's get a better view of this while it's rendering. So it's not rendering the first simulation. That is a bit strange over there. These are actually problems that you might run into here and there. It's actually quite important that you check if everything's working first. So let me just render this layer. Let's see. Okay. Clearly the camera is only rendering the fourth layer when we're previewing the third. So maybe there's something... of course. Hold on. Render layer. There might be some render layers over here that... Alright. apparently the camera is separate from the render layer, so that is a bit of a difficulty that we might be experiencing over here. Now I'm just going to enable both of these, and let's see what it looks like when rendered. So now it's rendering both of the layers, so let's check what it looks like. So far, so good. Alright, now it has finished rendering, only about 1 minute and 32 seconds. That is good because I'll end up adding later objects to the scene and they will cost a lot of render time. So this is definitely quite good. One thing that I can observe that I'm not really a big fan of is the fact that there is way too much blue and way too little red. So what's going to happen is I'm going to have to render the first particle simulation and the second particle simulation in different render layers. So when I'll actually start to composite them, I could darken the second particle simulation and keep the first particle simulation at the brightness that it is, maybe increase the contrast a little bit, and then I'll actually mix them. And that is what I'm planning on doing. I'm not sure if that's how it'll end up, but so far I think we are done with the shading. So right now you're looking at the final result, and that is about it for this video. Now, if you enjoyed this video, please leave a like and comment. I would certainly like your opinion on this new video format that I'm trying to do. This is only the first episode of doing random stuff, so the quality might be quite lower compared to the future episodes that might be coming. But anyway, that's about it for today. Thank you for watching.